Okay, in order to understand what's going on here, these are the formulas that you should know before you start working with mechanical system, mass, calculations. So let's just get into it. So this one we see on, you see at the top is just a derivative. Second derivative equal to this, what you see there. First derivative equal to this. Okay, you can also write it in that way if you want. The same goes to x. And further on, this is the mass when we have a force. Okay, Ft. So you're going to write it in this way. If there's no Ft, you're gonna write 0 equal to the mass, and so on. So this is what you get, and it's just the first principle. And this is also another way to, when we work with rotations. Okay, this is how you're going to represent it. And this one also, this is the formula that you get, because we have x1 and x2 depending on where the mass is connected. Okay, that means you're going to have a mass somewhere here at x2. That's why you see x2 first. Okay, and the same goes for rotation when you work with rotation. Okay, maybe O2 minus O1. So, and this one represented with this formulas. Okay, and since we have we can also write it in this way. B, first derivative of x2 minus x1. You can also write it in this way. That's why you see we have a dot. Okay, it's the same. And remember, when you have this component, you need to use the first derivative. The same goes for this one. You can also write this one like this: d dt minus. Okay, and further on, when we work with that, something like this, remember we have ft, so it will be ft equal to the x times k. This is what you see here. And here, since they are in parallel, we're going to add them. That's what you see, we're going to add them times ft. xt equal to ft. That's what you see here. Okay, we got these other formulas. This is when you convert your equation into S domain. So this is when you apply Laplace transform. So when you apply Laplace transform, so this is what you get. And what you see inside here for the second derivative, so this is what you get. What you see at the initial condition, if you are given the initial condition, this is where you can plug the value. Okay, so you can only plug the value for the initial condition into the first derivative and second derivative. The rest is gonna be just the same. But in a case that the initial condition equal to 0, so it's not given, or not given, so you're going to assume that the initial condition equal to 0. So, and then your equation is gonna be something just copy this block. So we actually only need this first derivative and the second for us to apply the. Okay, since we know that there's no initially condition. So what we're going to get into this equation, so it's gonna be 0. So this one is gonna be 0, this other one is gonna be 0, and this one is gonna be 0. So and then you're going to remain, the equation will be something like this. Equal to s square u s. Okay, in most of the case you're not gonna get any initial condition, so we're going just to get, when you're going to apply your Laplace, after applying your Laplace, you will get this one on the second derivative, this one on the first derivative, and we know already for this one I get just u2 s. Okay, now about the subscript, let's just something that just to give you an idea of how we can work this one around. So these are the important formulas that you need to know in order to solve the mechanical system. Okay, so you need to know these formulas, and there are also some formulas for rotation that I've added just in case. Okay.